Module 3 on borehole heat exchangers has a series of submodules, and this submodule 3.4 gives practical considerations for implementing successful drilling projects. So to start off with, we are going to look at the key project development process associated with geothermal projects. And you can see here a flowchart on the screen which demonstrates conceptually, let's say, the main steps with respect to implementing a geothermal project. As you can see, there is always an initial phase of feasibility where a preliminary concept of a geothermal collector or water-to-water heat pump solution is devised. And that requires specific inputs from the ground conditions and knowledge of the preliminary energy demand for the project to try and understand which one is the most adequate collector design solution. And this generally leads to an initial output of what the geothermal system might be able to deliver. The second phase, which doesn't involve some drilling aspects, which we'll consider more in the following slides, is generally a validation phase. So in that validation phase, in the project development process, we seek to drill and test specific subsurface conditions to validate the initial concept design of the project. We also spent quite a bit of time working on the final energy demand requirements of the project and ensuring that the geothermal solution is adequately designed to those. But the key thing is the output of the validation phase is a set of detailed construction specifications for the geothermal solution, and specifically in terms of the subsurface. That implies that a borehole requirement in terms of the depth, the number of boreholes, and specific completions in terms of the drilling diameters and the design for the final projects are defined. And these detailed construction specifications therefore feed into the last phase of the project, which is the construction phase, where we actually implement, drill, and install the solution prior to commissioning the system and handing it over to the client. So in this case, we are going to focus on the drilling operations and how these need to be aligned in terms of this project development process, but also what are the key considerations to ensure that such a process and a project are implemented successfully. So in terms of looking at the drilling operations specifically, one would consider that in the last phase of development, which is the actual construction of the geothermal collector, the initial geothermal system design specification has already been completed. So in this case, the system designer will have specified the borehole depths, the diameters, and the spacing that a borehole heat exchanger collector would have to be installed at. They will have also specifically carried out simulations to determine that the installation of the geothermal probes and the borehole heat exchangers is correct, therefore that the diameter has been selected based on acceptable pressure drop calculations, and that these calculations have also been developed in terms of identifying the operational parameters of the final system. At this point, the system designer will have also made a specification with respect to where a collector is to be located. They will have been able to identify the space and implementation requirements for the drilling operations of a specific area, and ideally will have carried out some initial work with respect to any services such as water mains, electrical cabling, or gas mains that may be already present at a site and have identified any other key infrastructure that may affect the delivery of the geothermal collector. And you can see here in the picture on the screen is an example of one of our projects developed underneath the slab of a new building post the completion of piles for the actual main building slab structure. So prior to the geothermal collector installation, the designer will have completed a design risk assessment to inform the drilling operations program. And this is really, really critical. And to review how to implement a design risk assessment, I would refer to Module 1 and in particular submodules 1.9 and 1.7 if you want to find out some more information.